Hey, we've got another integral from UNSW Integration Bee 2019. Problem 10, we have the integral of minus pi over 2 to pi over 2, 2x sine absolute value x over 5 plus cos 4x dx. Okay, I was thinking this could be a real trap because this looks pretty hard, especially throwing an absolute value in it. We have trig functions, but then we have an x. So this problem could be very hard and take a lot of time, or it also could be very easy. When you've got a difficult integral and you've got symmetric bounds like this, maybe one of the first things you want to look at is to consider if this isn't maybe an odd function. Okay, so over here on the right, we've got this property here that just tells us if we know that f of x is odd and the bounds are symmetric around the y-axis, the whole integral is going to be 0. And then just as a quick review, what is an odd function? Well, an odd function has this property here. If this function's odd, then if we plug into this function minus x, we'll just get back the negative of the whole function. Okay, so our function f of x is just going to be the whole integrand. We just want to show that this is odd. So from here, what I'm going to do is we're just going to look at f of negative x. Okay, so now wherever we see an x, we plugged in our minus x. We're going to get quite a bit of simplification. Now because we have an absolute value here, we can just kind of turn that one into a plus. That one's going to go away. And cosine is an even function. So a negative sign there can be ignored or turn it into a plus, whatever. Then we just have this one minus sign here, and I'm just going to bring this out front of the whole thing. So let's look what we have. We're going to have minus. So then when we rewrite this, we're going to have minus 2x sine absolute value x, 5 plus cosine 4x. But then we notice that what we have right here, this is just the f of x, right? So if we rewrite this, we can just write this as minus f of x. But that is exactly this definition of an odd function. Therefore, the whole integral using this principle is going to be 0. That's it. So you notice you can almost do no work on this, because if you recognize it, you can just like write in 0 and be done. So we'll stop it there. Thanks everyone for watching. Please like and subscribe. Have a good day.